So class, this is your review on scientific notation and standard form, and I just want to remind you of a few things so as you prepare for your quiz on Friday. So just remember, with scientific notation, we're going to be moving a decimal, and specifically, we're going to be moving a decimal from the left or the right. So let's go over the rules really quick. The first thing you need to do when addressing a scientific notation problem is look to see if the number is 10 or greater, or if it is less than 1. 10 or greater and less than 1. Once you decide what the size of the number is, what you're going to do is the rule says that if the number is 10 or greater, then you're going to move the decimal to the left. Okay? If the number is less than 1, you're going to move the decimal to the right. Okay, so that's the number one rule. So once you decide which way you're moving, now you got to move your decimal to the place that it needs to stop. Now remember that your decimal can't move past the number that is the farthest to the left or the farthest to the right. So it can't pass the last number. And it's always going to usually land between two significant figures or two non-zero numbers. So once your decimal lands where it needs to be, you need to remember that that final number is the number that you multiply times the base number of 10. So you take your final number and you multiply it times the base number of 10. Now, how do we get the exponent? The exponent is determined by the number of times that you move the decimal. It's determined by the number of times that you move the decimal. And the one thing you need to remember is that if you move the decimal to the left, your exponent is going to be positive. If you move your decimal to the right, your exponent is going to be negative. So we're going to go over a couple examples just to remind you so you can have a visual on how it's going to go. So we have this number right here. The very first thing we do when approaching a scientific notation problem is to determine whether the number is greater than 10 or less than 0. So when we look at 580,000, this number is 10 or greater. So now we know which way we're going to move the decimal. Just by way of reminder, when we have a number that looks like this, we don't see a decimal in the actual number because there is an imaginary decimal. We have an imaginary decimal, and we place that imaginary decimal at the number behind the number that is farthest to the right, behind the number that is farthest to the right. Now we've already determined that we're moving the decimal to the left because this number is 10 or greater. So we're going to move it to the left. 1, 2, 3, 4, 5. Why did we stop between the 5 and the 8? We stopped between the 5 and the 8 because we cannot pass the number that is farthest to the left. So it lands in between the two significant figures of 5 and 8, two non-zero numbers. So now we know that our final number is 5.8. Following the rules, we take our final number and multiply it times the base number of 10. Now we're going to work out getting our exponent. So when we get our exponent, we look at the number of times that we've moved the decimal. We moved it 1, 2, 3, 4, 5 times. Therefore, our exponent is 5. Now, what kind of exponent do we have? We have a positive exponent. The reason we have a positive exponent is because we moved the decimal to the left. So this is our final answer for that problem. Now let's look at another problem where it involves a decimal. A decimal is actually present. Again, when we approach problems that involve scientific notation, we determine whether the number is 10 or greater or less than 0, less than 1. This number is less than 1. So we know that we are moving the decimal to the right. Whenever a number is less than 1, we move it to the right. So now, we're going to move this decimal to the right. 1, 2, 3. And we're going to move it in between the first 2 numbers that are significant. And we know that this 7 and this 1 are both significant and they're non-zero numbers. So this is where the decimal is going to land. And of course, we have not passed the last number on the right according to our rules. So now we know that our final number is 7.15. We take our final number and multiply it times 10, the base number of 10. And now all we have left to do is to get our exponent. And our exponent is determined by the number of times that we move the decimal. So we move the decimal 1, 2, 3 times. So our exponent is to the power of 10. Well, we got one other step, and that's determine whether or not our exponent is negative or positive. We know that the exponent is negative because we move the decimal to the right. So that's scientific notation. Taking a number from standard form and putting it into scientific notation. Now what we're going to do is we're going to take a number from scientific notation and take it back to standard form. Remember when I told you standard form is the reverse of scientific notation. We're going back that thing up like we talked about the other day. So we're going to back the decimal up. So this is how we do. The very first thing that we do in approaching a problem that involves us going from scientific notation to standard form is that we know we're going back to the original number. We're going back to the original number. So we're going to look at the exponent to determine how many times we're going to move the decimal back. Okay? The exponent also tells us which way we're going to go. So if the exponent is positive, we're going to move the decimal back to the right. We're going to move the decimal back to the right. If the exponent is negative, we're going to move the decimal back to the left. So let's look at a couple of problems. A couple of reminders. That when we're moving the decimal to the right, we drop the decimal. We drop the decimal in the number. When we move the decimal to the left, we hold on to the decimal. So let's do a couple of problems for standard notation. So we have 9.3 times 10 to the negative 2. Positive 2. So that means we have a positive exponent, which means that we're going to be moving the decimal back to the right. We have a positive exponent. We're going back to the right. So with that being the case, we go ahead and remember when I told you, whenever we're going back to the right, we drop the decimal. So you see that we've done that here. So then we're going to move the decimal 2 times. 1, 2. Okay? And you can see this little hump right here. That's a placeholder. And whenever we have a placeholder, we're going to put the number of 0 right there. And so therefore, our final number is 930. Our next example, 421 times 10 to the negative 4. Our exponent is negative. So that means we're going back to the left. Our exponent is negative, so we're going back to the left. So that means we're going to go right here, and we're going to take the decimal behind the last number on the right, as we always do, because whenever we have numbers that look like this, we always imagine the decimal. So we're going to move 4 times to the left. Sorry about that. So we're going to go 1, 2, 3, 4. So we've got a hump here. We've got a placeholder. And so with this placeholder, we're going to put a 0. And remember, whenever we move the decimal back to the left, we keep the decimal. So we end up with the final number for our problem, which is 0.0421. And this is our explanation of scientific notation in standard form. Make sure you study, use the notes to review, and be ready for your quiz on Friday.